In this video, we will be solving a few multiple choice questions from trigonometry. I have taken these questions from the Maharashtra government textbook, 11th standard maths part 1, miscellaneous exercise of chapter 3. Okay, I said maths part 1 of 11th standard Maharashtra government textbook. So let's begin with these questions. The value of sine n plus 1a, this is like one angle, sine n plus 1a into sine n plus 2a plus cos of n plus 1a into cos of n plus 2a will be equal to what? Just in case if you're not able to read that properly, I'll write that down over here. It is sine of n plus 1a into sine of n plus 2a plus cos of n plus 1 into a plus, into cos of n plus 2 into a. Now, I want you to think of that entire thing or this entire expression as, think of n plus 2 into a as x. So here also we have x. Think of n plus 1 into a as y. So this entire term is also equal to y. And now the expression is of the type cos x, cos y plus sin x, sin y. So cos x, cos y plus sin x, sin y, that basically is cos of x minus y. So this becomes cos of n plus 2 into a, which was x, minus n plus 1 into a, which was y. If you expand the bracket, this is na plus 2a minus na minus a. So na and minus na get cancelled. 2a minus a will be a. So the final answer is cos a, making option B the right answer. Okay, so with that we continue with our second question. And in the second question what they are telling us is tan A minus tan B is x. Okay, we will keep that in mind. Tan A minus tan B is x. Cot B minus cot A is y. Okay, the value for cot A minus B will be what? You need to understand that cot of A minus B is the reciprocal of tan A minus B. And tan A minus B is tan A minus tan B divided by 1 plus tan A tan B. So that 1 plus tan A tan B goes in the numerator. So if you understand tan A minus tan B is already x, the denominator is already given to us as x. What about the numerator? 1 plus, we don't know what's tan A tan B. We might get it from here. So cot B minus cot A is like 1 upon tan B minus 1 upon tan A. They have said it is equal to y, and if you combine these two terms, you get tan A minus tan B upon tan A tan B. So you have tan A minus tan B upon tan A tan B. Tan A minus tan B, we know this was x. So take that tan A tan B here, take that y here, and you have y as, you have x upon y as the value of tan A into tan B. And that value is what we will put here. Here means here. 1 plus tan A tan B, right? And we just got tan A tan B as x upon y. So that's the value of our expression 1 plus x upon y, the whole divided by x. If we simplify it, it will be y plus x upon y upon x. So that makes it upon xy. And if you split the two terms, you have y upon xy, which is 1 upon x, plus x upon xy, which is 1 upon y, making option C the right answer. Okay, so I hope we are clear with the second one, and with that we go ahead with the third one. The third one is also a very easy question. It's just the first step that you should be able to think about by yourself, and this kind of a problem solving skill will require a little bit of practice. So keep practicing these kind of questions, and you will soon, with a little bit of practice, get into the rhythm of solving these kind of questions independently by yourself. They have said that sine theta is equal to n times sine of theta plus 2 alpha. We will write theta plus 2 alpha as theta plus alpha, and because this is theta plus alpha, I can write the left hand side theta as theta plus alpha minus alpha. Not even theta minus alpha plus alpha, it will be theta plus alpha minus alpha only, because now theta plus alpha can be thought of as A and alpha can be thought of as B. Okay, so on the left hand side, when you make an expansion of sine A minus B, which is sine A cos B minus cos A sine B, this would be sine of theta plus alpha into cos alpha minus cos of theta plus alpha into sin alpha. On the right hand side it will be n times sin of theta plus alpha into cos alpha plus cos of theta plus alpha into sin alpha. On the right hand side just open up the brackets, so you have n term with this, you have an n term coming with this as well. We can divide both the sides of this equation with cos of theta plus alpha. So when we do that, the first term here will become sin of theta plus alpha upon cos of theta plus alpha, which is tan of theta plus alpha. The cos of theta plus alpha here gets cancelled, and the second term left with us is simply sin alpha. Now here also you have to divide with cos of theta plus alpha. That will make the first term here as tan of theta plus alpha, and cos of theta plus alpha here is going to get cancelled. Here means this cos of theta plus alpha will get cancelled. So this is what we get when we divide both the sides of that equation with cos of theta plus alpha. The second term here is n times sin alpha. Okay. Now because we need the value for tan theta plus alpha, we can take this term on the left and we can bring this sin alpha on the right. So when we do that, we get plus sin alpha here. Let this term go on the left, so we will have minus n times tan of theta plus alpha into cos alpha. Okay. On the right hand side, if I take out sin alpha common, I get n plus 1 on the right hand side, and from these two terms I can pull out tan theta plus alpha into cos alpha common, so that would leave me in the bracket with 1 minus n. Now that cos alpha into 1 minus n, I can take it on the right. On the right I had sin alpha into n plus 1, right? So now I can take that cos alpha into 1 minus n on the right hand side. So that would give me upon cos alpha into 1 minus n, and sin alpha upon cos alpha will be tan alpha. So the final answer for tan theta plus alpha is tan of alpha into 1 plus n upon 1 minus n. And that's making option D the right answer for that sum. Okay. Let's move on with the fourth question. The fourth one is a simple one compared to the previous three questions. Cos theta upon 1 plus sin theta. We can write that as cos square theta by 2 minus sin square theta by 2. That's your numerator. And in the denominator, first write sin theta as 2 times sin theta by 2 into cos theta by 2. You can write that 1 as sin square x plus cos square x. But in place of x, prefer to select your angle as theta by 2. So write that 1, this one in the denominator as sin square theta by 2 plus cos square theta by 2. We had a plus sin theta. So this is plus 2 sin theta by 2 cos theta by 2. The numerator is a square minus b square. So that is a minus b into a plus b. That's making it cos theta by 2 minus sin theta by 2 into cos theta by 2 plus sin theta by 2. And in the denominator it is the expansion of a plus b the whole square. So in the denominator what we have is cos theta by 2 plus sin theta by 2 the whole square. So cos theta by 2 plus sin theta by 2, one of them gets cancelled in the numerator and denominator, and we are left with cos minus sin upon cos plus sin. Divide the numerator and denominator with cos of theta by 2. So that will give us 1 minus sin theta by 2 upon cos theta by 2 becomes tan theta by 2 divided by 1 plus tan theta by 2. And this is the expansion of tan pi by 4. The numerator contains a minus, right? So tan pi by 4 minus theta by 2. And that's giving us option A as the right answer. Okay. The fifth one. Now the fifth one is like a standard formula that you should remember. Nevertheless, I will be solving the entire sum for you. But like I have said, make sure to see that you are remembering this as a standard result in trigonometry. Cos A, cos 60 minus A into cos 60 plus A, cos A minus B into cos A plus B. We always write it as cos square A minus sin square B. Okay, so cos square 60, that would be 1 by 4. Let's write sin square A as 1 minus cos square A. And if I open the bracket, it would be minus 1 plus cos square A 1 by 4 minus 1 would be minus 3 by 4. So we have cos square A minus 3 by 4. Club the two terms and you will have 4 cos square A minus 3 the whole divided by 4. Take that cos A inside the bracket. So you have 4 cos cube A minus 3 cos A the whole divided by 4. But the numerator is becoming equal to, it's the expansion of cos 3A. So we have cos 3A divided by 4, giving us option C as the right answer. Now, this is a standard formula because you just need to keep in mind that if there's an angle given like A and you are having cos A, then the other term is again in cos with 60 minus A, cos 60 plus A. The expression is going to be equal to cos of 3A divided by 4. What if I give you a similar expression like sin A, sin of 60 minus A into sin of 60 plus A. Now that expression has the value of sin 3A divided by 4. Okay, so sin 3A divided by 4 is the value if the expression contains sin, that is sin A, sin 60 minus A, sin 60 plus A. The product is sin 3A divided by 4, and that same result with cos is going to give you cos of 3A divided by 4. How do we prove this result? Exactly in the same way like you proved this result, just that sin of A plus B into sin of A minus B, the formula says that it will be sin square A minus sin square B. Okay, you can apply that formula and get that derivation done for yourself. For now, I have done the derivation for cos and we have got our answer to the 5th MCQ. With that, I'll just go ahead with the 6th one. The 6th one is a very good question, slightly longer, but trust me, it's a really good question when you come to the solving part of it. Now, here the angles are sin pi by 14, like the angle is pi by 14, you have sin pi by 14, into sin of 3 pi by 14, sin of 5 pi by 14, sin of 7 pi by 14, and hang on, 7 pi by 14 is like pi by 2. So sin of 7 pi by 2, 7 pi by 14 is sin of pi by 2. Sin of pi by 2 will be 1. So I can just eliminate that middle term because it is equal to 1 and focus on the other terms. Sin of 9 pi by 14, 11 pi by 14 and 13 pi by 14. The bigger numbers, okay, that is 9, 11 and 13, we can make them smaller. If I consider sin of 9 pi by 14, I can write it as sin of 14 pi minus 5 pi upon 14. You can split that 14. So you get sin of pi minus 5 pi by 14. Sin of 180 minus theta was sin theta. So this becomes sin of 5 pi by 14. Similarly, check for sin of the second last one, which is 11 pi by 14. You can write it as sin of 14 pi minus 3 pi divided by 14. I'm just writing 11 pi as 14 pi minus 3 pi. Split the two terms. You have pi minus 3 pi by 14 and sin of 180 minus theta is sin theta. So this will be sin of 3 pi by 14. In a similar way, you can work out for this one by yourself. That would be sin of pi by 14. But if you look carefully at the values of these terms and the starting three values, check that they are all equal. Okay, so because they are all equal, of course, I will convert the bigger angles to smaller numbers, and when I combine them with the corresponding terms here, you realize that the entire expression is basically first term square into second term square into third term square. That is, the entire expression is sin pi by 7, sin pi by 14 into sin of 3 pi by 14 into sin of 5 pi by 14 square. Now, whenever we have terms in multiplication, it is easier to deal with cos than to deal with sin. So this term will be converted to cos in this manner. We know that sin 90 minus theta is cos theta, right? So try to bring a 90 at the first position. 90 means pi by 2. And if I want a pi by 2 in the first position, I will write that pi as 7 pi minus 6 pi the whole upon 14. That is how I am writing sin pi by 14. When we split them, we get 7 pi upon 14 minus 6 pi upon 14. 7 pi upon 14 is pi by 2. 6 pi upon 14 is 3 pi by 7. Sine of 90 minus theta is basically cos theta. So the first term is cos of 3 pi by 7. Into, try converting this in a similar manner. 3 pi will be written as 7 pi minus 4 pi. So this becomes pi by 2 minus 4 pi upon 14. And that makes it cos of 4 pi upon 14. But 4 pi upon 14 is like 2 pi upon 7. And the last term would be sine of 5 pi upon 14. So that is 7 pi minus 2 pi the whole upon 14. That makes it sine of pi by 2 minus 2 pi upon 14. That would be cos of 2 pi upon 14. But cos of 2 pi upon 14 makes it cos of pi upon 7, the whole square. I had written it down for the first term. For the next two terms, I have just said that orally. If you're not yet clear with how did I get these terms, try writing them down just like the first term and you will understand how did I get these two terms. Now, even with a cos term, we can deal with it easily if the terms are basically multiples of 2. I mean, not multiples of 2, but they are getting doubled from the smallest angle. Like if this is pi by 7, this had to be twice of it, which is 2 pi by 7. But then this had to be twice of 2 pi by 7, which is 4 pi upon 7. We can actually make it 4 pi upon 7 because we can think of it as 7 pi minus 4 pi the whole upon 7. So I can write it now as 7 pi upon 7 minus 4 pi upon 7. That is pi minus 4 pi upon 7. Cos of 180 minus theta is minus of cos theta. So this term is going to become equal to minus of cos 4 pi by 7. But minus square of minus 1 would be 1 only. So that minus 1 square we can take it out of the bracket and that minus 1 square is written as 1 outside the bracket. So whether you write it or no, it means one and the same thing. That minus sign vanishes and now we have terms the way we required them. Okay. So what we can do with cos pi upon 7, then we had cos 2 pi upon 7, then we had cos 4 pi upon 7. So what we can do is we can multiply the numerator and denominator with 2 sine pi upon 7. So we have 2 into sine pi upon 7. Now understand this, 2 sine pi by 7 into cos pi by 7 is going to make it sine of 2 pi upon 7. Multiply the numerator and denominator again with 2. So 2 sine pi upon 7 cos pi upon 7, that makes it sine of twice that 2 pi by 7, that is sine of 4 pi upon 7. Multiply the numerator and denominator with a 2 again. So 2 here and 2 here. So in the numerator it's 2 sine 4 pi by 7 and cos 4 pi by 7. That's making it sine of 8 pi upon 7. So we have the final expression as sine of 8 pi upon 7 divided by 2, 2 and 2 make it 8. Sine pi upon 7. I had forgotten the square here. So there's a square here. And sine of 8 pi by 7. Think about it. Sine of 8 pi upon 7, right? 8 pi can be written as 7 pi plus pi. And if you split the two terms, that is 7 pi plus pi the whole upon 7. That is what we had, right? This is sine of pi plus pi upon 7. Sine of 180 plus theta is minus of sine theta. So this will be minus of sine pi upon 7. And that is why the numerator is minus of sine pi upon 7. That minus of sine pi upon 7 and sine pi upon 7 get cancelled. We have the final value inside as minus 1 upon 8, the square of which is the square of which is 1 upon 64, and that's making option B as the right answer. It was a long sum. It had a lot of tricks here and there, and I would actually classify it as a level 2 type of question, slightly higher than level 1 questions. Not a very tough one, but yeah, definitely not an easy one. That is how we solve the 6th question. Go ahead with the 7th one. So alpha plus beta plus x is equal to pi. Sine square alpha plus sine square beta minus sine square x will be equal to what? So you can just write sine square alpha as 1 minus cos 2 alpha divided by 2. sine square beta is 1 minus cos 2 beta divided by 2, and that sine square x as 1 minus cos 2x divided by 2. Now if you just split the terms, it's 1 by 2 minus cos 2 alpha by 2, 1 by 2 minus cos 2 beta by 2, and here also it's 1 by 2 minus cos 2x by 2. If I just open the bracket, it is minus half and a plus here. And finally, if you check the terms, half plus half minus half makes you leaves you with simply a half. So that half is what we have at the very beginning. And from the remaining three terms, this was a plus here, okay? So from the remaining three terms, we can pull out a minus half common. So when a minus half is getting pulled out common from the three terms here, we have minus half cos 2 alpha plus cos 2 beta minus cos 2x. Now cos 2 alpha plus cos, this was a beta here, okay, cos 2 alpha plus cos 2 beta, that would be 2 times cos of 2 alpha plus 2 beta divided by 2, that is cos of alpha plus beta, into cos of 2 alpha minus 2 beta divided by 2, that is cos of alpha minus beta. Now cos of alpha plus beta, think about it. Alpha plus beta plus x will be equal to pi. So alpha plus beta is pi minus x. So this term is pi minus x, and cos of pi minus x will be minus of cos x. So this term is minus of cos x. So okay, now we need to even simplify cos 2x here. So to simplify cos 2x there, okay, we would prefer to write it as 2 cos square x minus 1. Should we write a minus 1 there? No, we shouldn't. 2 cos square x minus 1 is what we will write that last term as. Because when the bracket gets opened, this would be minus 2 cos square x, and this would be a plus 1. Start expanding. So this is half minus half into, you can pull out, okay, this is minus 2 cos x, cos alpha minus beta, minus 2 cos square x. Pull out a minus 2 cos x common. So we are left with cos of alpha minus beta plus cos x, and then in the end we have a plus 1. Cos x plus cos x is basically minus of cos alpha plus beta. We had just got it here. Cos of alpha plus beta was minus of cos x. So cos x has been replaced with minus of cos alpha plus beta. Cos alpha minus beta will be cos alpha cos beta plus sin alpha sin beta. This would be cos alpha cos beta minus sin alpha sin beta. And when you expand the bracket, the cos terms get cancelled and the sin terms get added. So this entire bracket turns out to be 2 times sin alpha sin beta. Okay. Now expand this entire bracket with minus half. So the first term becomes simply plus cos x 2 sin alpha sin beta, and the last term becomes equal to minus half. It was plus 1 into minus half, so minus half. So these two terms get cancelled, and this is the final value, that is 2 times sin alpha sin beta cos x. And that's making option C your right answer for the 7th question. Okay, with that we go ahead with the 8th question. A and B are two angles which are lying between 0 and 90, and they satisfy this condition. 3 sin square A is 3 sin square A plus 2 sin square B will be 1, and 3 sin 2A minus 2 sin 2B will be 0. You need the value of A plus 2B. So in the first expression, let's take that 2 sin square B on the right. So we have 3 sin square A is 1 minus 2 sin square B, but 1 minus 2 sin square B is like cos 2B. Take 1 sin A on the right. So we have 3 sin A as cos 2B upon sin A. And let's mark it as 1. I did that because I very clearly saw this condition where they had said 3 sin 2A minus 2 sin 2B equal to 0. So there was one thing which was very clear in my mind, which said that 3 sin 2A will be 2 sin 2B. Because I was getting 3 sin A from here, and I knew that I will have a 3 sin A from here. I tried to write this as equation 1, and from the second expression also we will try to bring the value for 3 sin A. This can be written as 2 times sin A cos A equal to 2 times sin 2b. Let that 3 and sin A remain on the left. 2 and cos A, take them on the right in the denominator. So we will have 3 sin A as 2 sin B upon 2 cos A. 2 and 2 get cancelled. So we have 3 sin A equal to sin 2B upon cos A. Let's write it properly. 3 sin A is equal to sin 2B upon cos A, and let's mark it as the second equation. So from equation 1 and 2 you realize that cos 2B upon sin A is sin 2B upon cos A, because both of them are in turn equal to 3 sin A. Okay, so because both of them are equal to 3 sin A, both of them are equal to each other. That is, cos 2B upon sin A is sin 2B upon cos A. Take that sin A here and take that cos A here. So we have cos 2B into cos A equal to sin 2B into sin A. Take that sin 2B into sin A on the left. We have minus here and equal to 0. Cos 2B cos A minus sin 2B sin A is the expansion of cos of 2B plus A. So cos of 2B plus A will be 0. So 2B plus A must be equal to 90 degrees. So if 2B plus A is 90 degrees, pi by 2, that is option B is the right answer. Go ahead with the ninth one. And the ninth one says, the ninth one says what? In triangle ABC, cot A into cot B into cot C is greater than 0, which means all of these angles are acute. If one of them, if it would have been an obtuse angle triangle, then one angle would have been obtuse and the other two would have been acute. Cot for that obtuse angle would be negative, but for the other two acute angles, cot would be positive. Cot for the obtuse angle will be negative and cot for the other two acute angles would be positive, which is why if one of them would have been negative, the answer, the product would have never been greater than 0. The product can be greater than 0 only when these three terms are positive, which is possible only when ABC are going to be acute angles. You might be wondering, what if two of them are negative? See, two of them can't be negative because you cannot have two obtuse angles in the same triangle. Okay, so only maximum one can be obtuse, but if one is obtuse, then this would have been negative, which is not negative, and that is why we conclude that all these three angles that are given to us are acute angles. Okay, so the right answer there will be option A. One last question in this video, and it's a good question. So tan 20, tan 80, cot 50. So we will write tan 20. We know that our reference number is 50, because even 20 and 80, think of it, 20 and 80, the middle number there is 50. I can write 20 as 50 minus 30. So I'm writing tan 20 as tan of 50 minus 30 into tan of 80 will be 50 plus 30 into cot 50 cot 50 is like 1 upon tan 50. Okay, tan of 50 minus 30 is like sin of 50 minus 30 upon cos of 50 minus 30, and tan of 50 plus 30 is sin of 50 plus 30 upon cos of 50 minus 50 plus 30. In the numerator, you have sin A plus B into sin A minus B. That will be sin square A minus sin square B. So that is equal to sin square 50 minus sin square 30. Sin square 30 will be equal to 1 upon 4. And in the denominator we have cos A minus B into cos A plus B. That is cos square A minus sin square B. So this is cos square 50 minus sin square 30, which is again equal to 1 by 4 only. Okay, and tan 50, should we write it as, okay, let's not write it as anything. Let's just keep our expressions the way they are. Okay, so this is what we finally have, and into we have 1 upon tan 50. Okay, let's multiply throughout with 4. let's multiply the numerator and denominator with 4. So we will have 4 sine square 50 minus 1 divided by 4 cos square 50 minus 1. Okay, let's divide the numerator and denominator with cos square 50. So when we do that, the numerator is going to become 4 times tan square 50 minus 1 upon cos square 50 will be sec square 50. And here it will be 4. 4 cos square 50 upon cos square 50 is 4. Minus 1 upon cos square 50 will be sec square 50. Sec square 50 can be written as 1 plus tan square 50. And in the numerator also we will do that. So we will write it as 1 plus tan square 50. Expand the numerator, we have a minus 1 and a minus tan square 50. So 4 tan square 50 minus tan square 50, that is making it 3 tan square 50. And we had a minus 1 there. So this is 3 tan square 50 minus 1. And in the denominator it is 4 minus 1 minus tan square 50. So it is 3 minus tan square 50. And with that we can take tan 50 also inside the bracket here. So this will become 3 tan 50 minus tan cube 50. We can also pull out a minus common from here. Write this as 1 minus 3 tan square 50 and into minus 1. Now if you realize, see, this expression is like 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. It's the expansion of tan 3 theta. So this expression becomes 1 upon tan 3 theta is basically there in the denominator. We have tan of 3 into 50, which is tan of 150. Tan of 150 is like tan of 180 minus 30. Tan of 180 minus theta is minus of tan theta. So this becomes minus of tan 30. This minus and this minus get cancelled. Tan 30 is 1 upon root 3. And 1 divided by 1 upon root 3 will give you a root 3 in the numerator, giving you option A as the right answer. This is where we are done with whatever MCQs I wanted to discuss in this video. I hope that the contents have been helpful to you someplace somewhere in your preparations. Thank you for watching.